Hey, good evening, everybody. We're up to Friday. The weekend is here for the big eclipse coming up on Monday. And I've got a little video here to show you from earlier. I'm doing things kind of manually here, so just kind of bear with me. Let's see if I can get this to come up here. I've been battling Sony Vegas for the past hour. It's gotten to be kind of unstable, and I'm probably going to have to end up rebooting the system, but that kind of put me behind the curve tonight. So we're just going to go ahead and kind of wing it here from the raw files. And this is the sun earlier today. I took some $5 Eclipse glasses and put them in front of the lens of the camera and got this image here. And I don't know if you can see it. There's some sunspots here. I think right there. That's AR 2671. And that sunspot group measures about 125,000 miles across. If you were flying in an airplane, it would take you 12 days, like on a Boeing 787, to cross all of those sunspot activities. And just one of them is twice the size of the Earth. It's really incredible how huge the sun is, and just the scale of things. Okay, on to the charts. There we go. There's that last look outside. And what we got here, a little bit of thunderstorm activity up on the northern plains. And that's coincident with the return of some moisture up to the northern latitudes of the plains there. Also some pretty good thunderstorms in the northeast U.S. Let me take a look at chat over here and see what we got going on. Probably a little bit light as far as numbers tonight because I set up the webcast at the very last minute. So I think people are just going to be kind of dropping in. We got Ron Chalfant and Alexi joining. Ryan from Asheville, North Carolina, instead of Florida, from the Great Smokies. And oh, okay, Ryan sent some pictures. I've got to go through the email, so it's going to be probably one of these next webcasts when I get to that. We got Fun with Tech here, Burl H. Jeff Lockwood from West Helena, Arkansas. Every bit as muggy as back in Florida. Heading to Joplin and then Manhattan, Kansas. Sounds like that's for the eclipse here. We have Kevin McKinney here. Ron Chalfant mentioning strong storms in Kramer Junction near Barstow. So I guess that's just north of your mountains, I'm guessing. And David Moore joining us, and yeah, our numbers are coming up. Now, my trials and tribulations here with the Sony Vegas program means that I have not gotten a chance to really go into detail with the models for the Eclipse, but we can do some of that as we go. I have looked at some products, and I'll show you those towards the end here. 500 millibar pattern. This is up at about 18,000 feet. Earlier during the week, you can see we had this troughing that cleared British Columbia out, got rid of a lot of that smoke, and kicked into the prairie provinces. So that trough has kind of worked its way onshore and through the prairie provinces there. And now the charts are looking like this. Bit of a trough over the Great Lakes area, ridging building in. And we've got some more troughing out in Alaska, the Gulf of Alaska in that region. With this troughing here, we're going to see a low pressure area form aloft out on the west coast, and that's going to affect the weather here on Monday. That may send a little bit of cirrus into the central U.S. Okay, heading into the Canadian charts. I don't have the fancy overlays here, but what we see is a pretty mature frontal system here in Alberta adjoining areas of Northwest Territories and British Columbia. So this is kind of like the start of a shift to a fall-like pattern. Very well-developed system here. And temperatures, this is 18Z, so that's going to be late morning. Pretty cool here. 40s and 50s throughout Alaska and Yukon. Further south, you can see the much warmer air. This is in Celsius, and we see readings here of 77 starting out the day in Saskatchewan. So this is a big warm sector. Out to the west, there's the cool air coming in, and things are going to stay pretty much to the north, and we're going to be grazed by systems for this eclipse here. Okay, let's see if we can go aloft. Had trouble loading some of the UCAR products, and I don't think we're going to get that, so we'll just go to the Canadian analysis. And this is showing us the jet stream over the central U.S. Strongest winds appear to be in the Chicago area. Got 80 knot report right there. So that's a polar front jet, and it's kind of on its way out. And we're going to start building this ridge in for the weekend. And we can see the subtropical jet coming up from the southwest. Some 50 knot winds over Flagstaff. And let's take a look at the moisture field. I guess we're not going to get our charts from UCAR, so we'll have to go to a different source here. For 850 millibar analysis, we can do College DuPage. So they've got a pretty good analysis site. You just go to Weather Analysis Tools and go to their analysis data, upper air maps, and we can go pretty much straight to the 850 millibar charts. So there's our 850 charts, and it's been a while since I've talked about this, but the moisture on the plots here, is that dew point or is that dew point depression? Well, you have to kind of look at the values around the chart and go up to the north and see what things are looking like right there. Let me bring that back up. I lost the chart here. Okay. Every time I move away, okay, I'm going to lock that in right there. Okay, so now it's not going to do anything here. Okay, 850 millibar chart. So what I'm looking at is the values here. I don't see any... what I'm looking for is very high values in Canada. You should not find values of 15 or 20 degree dew points up in that area. And what I see here is 6 and 6 and 8. So that's about what we would expect with a dew point depression. But it could also be dew point here. Okay, so I'm looking around here. See, they don't give you the station plot models. You know, some sites will actually print that out. So I'm kind of working through here, and I think what we're looking at is actual dew points, because Dallas-Fort Worth here, see that 13 and 14 at Oklahoma City, that's going to be 50s dew points. And I don't think we have a bunch of dry air coming up from the south. So that's kind of the thought process I use to work that out. And you can confirm that by going to the SKU-Ts. There's the Fort Worth SKU-T for this morning. And yeah, we've got some pretty decent moisture there, ranging from about 15 up to 18. So we're definitely looking at dew point temperatures. Okay, so why is that important? because that's how we locate our areas of moisture. So very high moisture values concentrated in the Great Plains right here, and then drier air coming in from the north. Looks like an 850 millibar front coming southward. And the best moisture axis, that appears to be concentrated from West Texas up to the Kansas City area. So it appears that moisture is just going to continue working its way to Illinois, Indiana, and then we'll get the ridging building in aloft. And after that, we'll have to go to the models to see what's going to happen. Satellite's always good to look at. You can see the clearing with that frontal system coming out of Canada. Remember that troughing we had up in Canada? That's the cool, dry air coming southward. And it looks like we've got a bit of an outflow boundary here in Minnesota. See that right there? Very neat details. And what you're seeing here is the drier air from aloft coming down to the surface and displacing a lot of the moist air surrounding that region. And I'm kind of curious if we can see that on the mesoscale analysis. So obviously that outflow air covers all of southwestern Minnesota into the adjoining areas of South Dakota and then the corner of North Dakota. Okay, so let's go back. I'm going to plot the dew point. Okay, so yeah, we do see kind of the depressed values here, 66 degree dew points, but there is a lot of smoothing. The boundary is actually located kind of like this, and it looks like that gradient has been kind of smoothed over. So this is where it really pays to do detailed hand analysis to resolve those fields. Now what we can do is we can go to the deformation product, and sometimes that'll pick out the outflow. I don't know, very hard to tell. This is apparently it right here, and if I was just picking this chart from scratch, I would probably not be able to find that very well. But with this chart, I can kind of match this up with the satellite, and that's the outflow pool from this cell here, creating a bit of a meso high in this part of Minnesota. Do we have cooler temperatures coming southward? Not really. It looks like it's mostly dry air. Plenty of warm air up in Montana, 90 degree temperatures out in that region. Leading edge of the front, something like this right here. And most of the cold air is confined to the Great Lakes area. We've got lots of 60 degree readings. So it looks like we have a warm front in the Iowa and Illinois area right there. So this is good. We're getting a little bit of mesoscale analysis practice as we get into fall here. Very strong temperature gradient right there. So I'm probably going to place a warm front through central Illinois into central Iowa, and then maybe kind of a weak cold front like that right there. And then from there we may have an occlusion going northward like that. Okay, does that match up to the thickness chart? At first glance, no, not really. I mean, I can kind of see the cold pool right there. There's the troughing, the thickness troughing right there. So, yeah, there's probably a very weak system. Definitely the concentration of thickness where the lines are packed together, they're a little bit tighter in this area right here. So, yeah, there's a little bit of support for a weak system. So this is mostly kind of a baroclinic system moving southeastward. Not very resolvable on the synoptic analysis, but definitely at the mesoscale it's there. And then up in British Columbia, a very strong front, the one I mentioned earlier. There it is coming into Idaho and Manitoba, or Alberta. And looks like the warm front is probably something like that right there. 540's thickness showing up in Alaska there. So things are definitely cooling down. 540 in the central U.S., that would be indicating snow. That's usually about where the freezing line is. Okay, so we're building up this analysis of what's happening. So let's get some of the forecast products set up here. And before I go any further, I guess I'm going to turn to the tropics because we've definitely got some action there. A couple of waves through the Atlantic right there. And we've actually got a tropical storm just past Trinidad and moving into the Caribbean right there. There's what NHC has, and we've got Harvey. Winds up to 40 miles an hour sustained. And central pressure 1005, that's pretty high. But a couple more waves lined up, and we've been watching for those to have the potential to move towards Florida, towards the Carolinas. Let's see what they're going for here. 5-day tropical outlook, bringing one of the waves right up to the Bahamas and towards the Florida coast. So we'll be watching that next week. The other one, pretty strong recurvature here. Okay, so we're going to look at the water vapor imagery, and then I'll catch up on chat here. A little bit of a dry subsident area over northern Oklahoma. Okay, Alex says, how did you learn so much about geography? I think I studied geography before I studied meteorology. When I was 4, I remember giving my dad $2 out of my piggy bank and asking for a Rand McNally Atlas of Europe because we were moving to Germany at the time. So I was really into maps, and my dad brought back charts from, he was in the Air Force, and I would go over those, and I've got very, very familiar with geography. And you kind of have to be a student of geography to really be able to forecast, and you have to know where the mountain ranges are and a lot of the local effects like that. And to be able to brief, you have to pretty much know what areas you're talking about. And yeah, I was Air Force weather for 10 years there. Sue M is joining us, and Biltmore residence being incredibly suitable for viewing the eclipse. The watch is in full effect on the tropics from Ryan there. Going to be hot in Denver tomorrow for Mike Estwick, yeah, with that ridge coming on down. Mid-70s dew points in the Metroplex right now. Tornado warning for Iowa. So I guess we're talking about that storm right here. So we'll take a look at that. David Moore seeing some buffering. Eclipses and hurricanes. Michael Burrell 13. And Ryan will be back in South Florida on the 22nd, the day after the eclipse. Okay. All right. Is there anything to look at on radar? Maybe I'll pull up... I'm thinking, I wonder if I can bring up radar scope. That's always fun to use. Maybe I can get that going here. Okay, for radar scope, we're going to need a program called X-Mirage. And then I'll have to turn on AirPlay on the iPad. Okay, so we're going to look at radar scope here. Okay, airplay coming up. Now, radar scope is probably one of the best viewers on mobile devices for looking at radar data. And I think we're coming up here. Okay, so we're looking at my iPad here. See if I can shrink this down. Oh, that sucks. It's only cropping the... Oh, wait. No, I guess... Okay. I couldn't tell if it was cropping or rescaling the image. But anyway, there we go. There's the Dallas radar. So, if I want to look at another radar site, one way you can do it is zoom out like that. You kind of pinch it. You bring up the radars. I don't think it's showing that, but there's an icon here for radar. And then what I do is I tap on the radar site I want to look at. So some of these actions are actually not going through, but if you follow along, yeah, I'm going to go up to Sioux Falls here. So there we go. There's our storm on radar scope, and I've got the optional lightning data that adds a couple dollars every month, and I decided to subscribe to that and check it out. And you can see the outflow boundary right there. That's the back end of that. And you can see the hook. It's a classic northwest flow shape. Supercell kind of turned 45 degrees from what you see in textbooks. And the stronger reflectivity, the vault is right in that region right there. And there's a close-up look at that. Definitely a supercell. And let's try to bring up the velocity. Super res velocity. Okay, we've definitely got a very tight couplet. So yeah, take note of that. That is a pretty much, let me see if I can drop some of this lightning data here. Yeah, so this is a classic tornadic signature because the couplet is not spread out over a wide area. It's pretty much back to back across these radials. So from here to here, we're only looking at maybe half a mile. And let me see if I can bring up velocities. Yeah, there's a tool at the top called Inspector. Okay, so negative 51. Negative always means toward the radar. And fortunately, it has this little pointer. I don't know if you can see this. Let me try to zoom in on that. Okay. Well, that's not showing up very well, but it's pointing towards the radar, which is up here. Okay, so that's the inbound, and then we have down here the outbound, 61 miles per hour. So that is about 110, 120 knots of shear just southwest of that town of Melvin. And we'll go back to the reflectivity. Oh yeah, this is a good example. This is composite reflectivity. And you can see how due to the overhang, you cannot pick out the hook echo. All of this is overhang, and it just completely wipes out the shape of the hook echo. If I go to the base reflectivity, I get a much different presentation. So when you're trying to find low-level echoes like the hook, you're going to use that base reflectivity. And composite reflectivity is best for looking at areas of hail coming together, for looking at convective initiation, because that'll normally form up at about 15 to 20,000 feet when storms get going. So you want to be looking at those higher levels, and composite reflectivity is a good way to do that. Okay, so that's about all I got here for the radar. Okay, so I hope you enjoy that. Let me shut off the AirPlay. And we'll get back to our show here. So now it's about time to look at the forecast. High resolution rapid refresh for 0Z. We're getting some of the frames in here. The storms in Arkansas. Looks like tonight those will be dying down. Yeah, some of it goes through Little Rock here around midnight. So we'll probably watch for an outside chance of severe weather there as that moves southeast. And that'll be gone probably by dawn. Pretty quiet across Texas, bringing up that southerly flow from the Gulf. And let's take a look at the Midwest. We've got that warm sector coming up to Iowa. There's that tornadic storm right there. So what we're going to see here is this stuff dissipating, and we've got an MCS coming together in Missouri. So that's going to be forming up in northern Missouri this evening. And that'll track southeast down the Mississippi River through the St. Louis area towards Paducah, and then dying out there right around dawn. So definitely some rain for Illinois and parts of Missouri for tonight. So that brings us to the NEM. And this is going to come within range of the Eclipse. So we're going to be able to see some of the preset products. Okay, there's that MCS tonight. And just for the record, this is the 18Z run. So we don't have the benefit of the evening radiosonde data. But we'll just, try to use it the best we can. Okay, for Sunday night, this is when the low-level jet is going to get started somewhat. Because I noticed the wind speeds kind of pick up here at 850. So we're going to watch for a little bit of development up in Nebraska, South Dakota, Minnesota overnight. Monday morning is going to be looking like this. Looks like MCS developing over northwest Iowa, shifting by Monday morning into Wisconsin there. Okay, then what happens during the day? This is what's critical. Looks like a little bit of probably elevated convection in northern Iowa. Looks like maybe a little bit of wraparound here in South Dakota. And I'm trying to figure out when this convection peaks. Oh yeah, it really gets going well after the eclipse on Monday night. You can see an MCS coming together. So if you're driving back to Chicago or to Wisconsin, I can see that being a problem there. But let's see here. Yeah, it actually looks pretty good for Nebraska. So some storms will be affecting Minnesota. We talked about this yesterday. This area is going to be cloudy here. So chances for seeing the eclipse kind of low through here. And then I think we're going to be looking at good conditions in Nebraska. Kansas, I'll have to check the upper level relative humidity. But for now, that looks fine. Okay, I don't see any big problems in the southeast. You can see by 0Z the evening, only a few scattered showers around the mountains northeast of Atlanta. So I don't think we're going to be dealing with a whole lot of cumulus and that kind of thing. However, we do have moist advection coming up from the south, which means stratocumulus layers. So we're going to kind of watch for that. I think the main impact is probably going to be in the Arkansas area, parts of the Gulf Coast, maybe around here, and then maybe a little bit indeterminate in the Atlanta region. Looking pretty good for Wyoming with the troughing aloft. We're going to see convection developing during the day. That's going to start over the higher terrain. So I think Casper is probably going to be okay. Most of the valley areas should be fine. And then as those start putting out the anvils during the early afternoon, that will cut down a little bit on some of the clear skies. And then things looking pretty good for Oregon and Idaho. I don't see any problems there really at all. Okay, how about that upper level moisture? Let's take a look at the 250 relative humidity, 200 relative humidity. This is up at 40,000 feet. And so what I've been concerned with is that subtropical jet coming up from Arizona. Because typically south of the jet, we will tend to see cirrus layers. And it looks like that is definitely the case in Texas, maybe parts of Oklahoma, definitely out near Lubbock, Roswell. So we're going to watch for that. And it appears some cirrus is coming. Okay, hang on. I got to move this forward. Sorry, I got tricked here. Oh, cool gravity waves. Look at that. That is some very neat detail there. Okay, let's advance this up to eclipse time and redo this from scratch. Okay, so there's the jet. And it looks like it's going to be kind of a dry jet, which is good. You can see most of the cloud material. This looks like convective debris. El Paso, Lubbock, Childress, probably some scattered to broken layers. Maybe Deming, Las Cruces. And then you can see things are looking very good for Colorado. Western, possibly central Nebraska looking good. Lots of dry air aloft. We like to see that. And then maybe a little bit of cirrus coming through Wyoming there. Looks like possibly a little bit of cirrus coming down into Oregon also. So we're going to have to keep an eye on this here. But otherwise, in the low levels, it will be dry. 300, let's check that out. That's going to be about 30,000 feet. Run this up to eclipse time. I'm sorry if this is causing any lag on the stream. It's loading up about 15 frames here. But we're doing the best we can. So you can see how the clouds would have been a problem if this eclipse was on Sunday. Lots of moisture advection in the plains and lots of humidity aloft. But Monday looks like a little bit of a different pattern here. See, there's 18Z, and yeah, okay, now, yeah, it is bringing up a little relative humidity at 30,000 feet there, so we are going to have to kind of keep an eye on the prospects for cirrus in Nebraska. But these relative humidities, these are only about, you can see down on the bottom, we're looking at values of about, ranging from about 50 to 75, and it's really about 70 that you need for cloud material. So anything in that band, that's going to indicate cirrus. So it looks kind of patchy. I don't think it's probably not going to be overcast. Maybe a different story through Idaho and Yellowstone. Model indicating there are some possible overcast layers, but that will be advecting eastward. So if you're heading for that area, you might just have to relocate a little bit to the west, and then you'll be fine. But, you know, we've got a couple more days of looking at models to really nail this down. Okay, let's check out the 850 millibar relative humidity. This is going to be about 5,000 feet, and this will delineate the areas of stratocumulus. I'm going to try, I'm going to load that up manually so we're not buffering and stuff. Okay, so definite stratocumulus over Arkansas. This is moisture advection, a little bit of lift in the lower levels, affecting a lot of the southeast U.S., the lower Mississippi River Valley. Okay, so this could be a little bit of an impact, but I think we will have some breaks. Unless we have like a lot of isentropic lift, I don't think this will really amount to a lot of overcast during the afternoon. So I wouldn't be too concerned about this just yet. Because if we did have a lot of moisture, we would see thunderstorms breaking out here in the afternoon on the forecast, and that has not been the case. Soundings along the totality line. Looking like this, definitely some steep lapse rates. Okay, that's going to be a little bit of a concern. However, the moisture is not too rich. We're only looking at dew points of about 15 to 16 Celsius. The only thing that would concern me is this inversion, which means if we do get the cumulus developing, we could see some stratification there, mid-clouds at about 700 millibars. See that 700 millibar layer? So we might want to look at the 700 millibar relative humidity. And this would tell us where stratification could be a problem. Looking pretty good there around Nashville. It could be because that subsidence layer is a little bit lower. Let's see if that's the case. Yeah. So we're a little bit above the inversion there at Nashville. Stratification could be a problem there, a little bit lower there at Nashville, but we'll just kind of keep an eye on things. Doesn't look like any really high humidities in that inversion layer, so we may be okay there. And it's good to see a little bit of that dry air aloft in the mid and upper levels. That's going to definitely help with keeping the overcast conditions away from the viewing. So actually, I think this is pretty good. The only real problem areas I think are going to be South Carolina. I would probably plan on relocating west if you're going to be in the Charleston and Columbia area. But we'll look at that tomorrow and see how things are going. All right, let me take a look at the chat. I don't know if anybody's lost or having any problems. Ryan Toomey is concerned about the cloud layer in Asheville. Yeah, anywhere along the Appalachians. Maybe I can bring up a topographic map here. Because this time of year, orographic effects can play. That's where your cumulus clouds will tend to develop during the midday hours. So basically where you see the higher elevations, the red shading here, that's where we're going to see scattered or broken layers developing probably around the time of the eclipse. So those are just really not good places to be. You're going to be in better shape if you can get away from the mountains. I'm not saying this is going to be a whole big area of overcast. Probably nothing like that, but there's going to be patchy, scattered or broken layers around the higher peaks, and you know, that will be a little bit of a concern there. But we'll check that out in more detail tomorrow. The models will be getting a little bit more accurate as we get closer. One thing I did take a look at is on, I took a look at model verification. I don't know if anybody's been doing this. This is where we compare the different models. Like, for example, here, I'm looking at the GFS, which is red, and I'm looking at the NAM, which is green. So I'm trying to get an idea of consistency of the models. And this is a forecast time for Sunday night. We're not quite close enough to where we can evaluate the eclipse weather and compare the different models. But what I'm seeing is that the fields are pretty close. There's some fairly good consistency in the northern stream between the GFS and the NAM. A little bit more indecisiveness in the southwest here. You can see the NAM going for kind of a larger trough here, larger and deeper, and the GFS not so much. Also in the southeast U.S., GFS is going for a bigger ridge spreading in. So that would help to kind of maybe suppress some of the cloud layers there. NAM looking a little bit more pessimistic for the Carolinas there. And another way you can evaluate the models is by looking at the performance of the models. You can see here we've got a prediction for 18th at 0Z. So that's basically right now. No, 18th 0Z, I'm sorry. That was for last night. But in any case, the blue is the actual observed weather. So the blue lines in here, these are what are important. So which field is closer to the blue lines, the red or the green? Well, in terms of the Great Lakes, the model performance has been better with probably better with the NAM, going for a little bit more troughing in here. You can see the green, see that green line right here? It's pretty much capturing what actually happened there in blue. And the GFS did not capture that quite so much, went with more of a flatter appearance. And then for like the timing of this wave out in the Pacific, we can look at that. You can see that the blue is more aligned with the red out in this area, and the green looks like it's out of phase. So the NAM did worse in this area. And that's not a surprise because the NAM is a limited area model, which means you can have conditions on the edge of the boundary creeping in and causing problems. So I'm taking the NAM with a little bit of a grain of salt, but I do like the performance I've been seeing. It's been pretty accurate. It is being fed with data from the GFS and some of the other models around the edges, and I think that has actually been helping a lot. Okay, for surface systems, what am I seeing here? Again, the blue is what actually happened. And I think the NAM kind of nailed the features a little bit better in the Great Lakes. GFS went for a little bit more south. And probably a little bit... can't really tell if that's deeper or not. Okay, so that's kind of how we evaluate the models. Overall, pretty good performance, no big problems with either of the models. So you can use both of those in your forecast. Okay, so to kind of wrap things up, maybe I can bring up one other kind of chart to look at our forecast. Let me see if we have something with clouds here. Cloud cover. Okay, give me just a second here. I'm going to bring up cloud cover from the GFS. And we're going to look at the eclipse time. This is the 18Z GFS. Okay, there you go. And eclipse time is about right. Let's see, do I have that right? Yeah, there it is, 21st at 18Z. Okay, so you can see the big problems that we have up there in Minnesota and Wisconsin. And a little bit of that cirrus, it looks like that's impacting Kansas. But, like I mentioned, there is a lot of dry air up at 200 millibars over Colorado into western Nebraska, and that'll probably... We'll probably see kind of a similar picture there at 300 millibars, so I think the viewing possibilities in Nebraska are looking good. Kansas City, I'm not too sure about this. I'm going to put that in blue. I'm a little bit worried about that area. I don't see any big problems in the Paducah and Boot Heel of Missouri area. Maybe some stratocumulus layers might be an issue there. However, we do have a trough off the Gulf Coast there, kind of a tropical disturbance, and it appears that that is going to give us some warm, moist advection into Georgia. So probably what they're showing here with South Carolina having problems, I think that is pretty much going to be the case. But as you can see in the Appalachians, I think we're probably lucking out there. Most of the problems there should be kind of local. Okay, then heading out further west again, you can see that area of cirrus. Biggest concern there for Yellowstone, for the Twin Falls area. Would that be Twin Falls? I'm trying to remember the towns here. Maybe Pocatello. Basically eastern, far eastern Idaho. That's a concern area also around Butte, Bozeman, Billings, and up into eastern Montana there. And you can see clear skies in Oregon. And that area of high relative humidity that was spreading southward that we saw in the RH charts, looks like we don't have much to worry about. GFS is keeping things kind of clear there in Oregon. So I think all things considered, we're doing pretty well. You know, the path could have gone like this. That would have been pretty bad. So I think there's a lot to be grateful here for. All right, so that's basically the cloud forecast from the GFS. Let me see if there's one for the NAM. And then we'll just wrap it up here. Yeah, there we go. I'm going to do a little bit of wizardry here in Paint Shop Pro. Because it looks like they're using the same background maps here. So that means we can do a little bit of comparison. Now this is the NAM forecast, and you can see, yeah, there's those clouds there in Yellowstone. Eastern Idaho, that's agreeing with the GFS. But the model is a little bit more optimistic as far as coverage, less problems there. It is going for a little bit more patchy coverage of cirrus in western Nebraska. So yeah, that probably is going to be a concern there. Things looking okay, I guess, for eastern Nebraska there. Not so much cloud material through here. There is disagreement with the GFS in this region here. And then we pick up the worst cloud material there in South Carolina, and I guess they will be pretty much shut out. But Tennessee, I think that's looking good, and Paducah looking good. St. Louis and Kansas City, I'm just not too sure about those just yet. Okay, so what I wanted to do is capture this. Can I capture that? No, I'll have to do a print screen. So I'm going to suction this off. I'm in a Paint Shop Pro, by the way. Okay, so there's our NAM. Let me grab the GFS. Okay, so I hit print screen, and I'm going to section that off also. Now what I'm going to do with these is I'm going to run a layer on these. So I'm going to copy that to the clipboard, and then I'm going to paste the GFS as a new layer. Okay, so there it is. It pops in there. Let me move this so you guys can see. And then I'm going to go to this layer component and switch that to one of these alternate fields here. Now, as far as which one is better, I'm not too sure. Oh, here's a good way to compare these. Let's do this. Let's go back to normal. I'm going to colorize those with a different color, red. Okay, let's blend those now and see how things look. Okay, so now we've got kind of a useful product here. Let's see which one looks best. Yeah, I think probably that darken one looks a little bit better. So you can kind of use this to kind of find consistency between the models. For example, in Wisconsin, Minnesota, lots of consistency. So they're going to be completely shut out. Green Bay, Madison, probably the Chicago area, and Minneapolis right there. Lots of disagreement with the models in Kansas and Missouri. Okay, so we're going to have to keep an eye on that. Good agreement with the models in Idaho. So we can probably pretty much count on there being a problem in western Wyoming. Things are agreeing very well out in Oregon. There's good agreement with the clouds here, and you can see the sheet here on the GFS. It's the pattern is very similar to the NAM, but the details are a little bit different at the mesoscale level. But I think there's probably going to be a few breaks here and there. And then you can see Tennessee, Paducah, that's looking good right there. So to sum it up, I'm going to do red for bad. Looks like problems in western Nebraska. This agreed very well there. And then the good areas, looks like Casper, Douglas, that's looking good. Paducah, Nashville, some good consistency between the two models there. And then this area here is kind of indeterminate, but I think it will be possible to find breaks, especially in Nebraska. But we've got 2 more days to look at things, and I'm going to save this. That way tomorrow we can pull this up and see what kind of consistency we've had, to see if the models are getting any better. Sorry about this. I'm just kind of, I want to get that saved so I don't forget about that. Do I have that lined up? There we go. Okay, there we go. All right. So I'm going to lock that in. I'm going to go to Layer, Merge, Flatten, and then I'm going to save that. So we're going to do this cloud blend tomorrow. If I'm doing the weathercast, I'm going to bring my laptop. I'll probably be in Dallas tomorrow, so things may be a little erratic. But if I'm on, we'll try to do this comparison here and see how things are looking. And then Sunday, I'm probably going to be on the road heading up to Nebraska unless we're washed out. And then Monday, coming back to Dallas for the return from the eclipse. Okay, so let's finish up here. Fun with Tech 7-day forecast for St. Louis is mostly sunny. Is Missouri a total loss? Like I said, it's indeterminate. We've got some disagreements with the two different models due to differences in the moisture surge, the low pressure area in the Great Plains. The positioning is kind of different. Let me see if I can show that to you here. Yeah, this is a comparison with the GFS in red and the NAM in green. And there's a positioning error with this low pressure area on Sunday night. Or I should say inconsistency. So the red GFS has got development up in this area, Rapid City, and then the NAM has it a little bit further south, kind of down in this area, or maybe even a little further south in Kansas. And you can see the warm front, this troughing in here from Nebraska into Iowa. So there's going to be a warm front in that area, a low-level jet coming in from the south, and probably some isentropic lift, and moist advection coming up from the south. So these are some dynamic processes, and with this position error, we just don't really have too much agreement with what's happening there in Missouri and Kansas. But I think by tomorrow, things should work out, and we should see some better agreement there. So I would not change your plans too much. Okay, I'll go ahead and finish up here since we're kind of running late. I've got to go to storage and pick up a couple of supplies for the trip. Kansas City, 30% chance of rain from Fun with Tech, but there are fundamental model disagreements in that area, so don't worry about it tonight. And yeah, Monday at 18Z, that's what I've been working with. That's 1 p.m. on Monday Central Time. Okay, so that's about all I got for tonight. I can see if the viewer's dropping off a little bit by bit, so I think we've hit all the main topics we want to cover. So we'll do our closeout music and be done. Anyway, thanks for watching. Please monitor Twitter for what I'm going to be doing for the webcast tomorrow night. I'll post an update there, and we'll just see what happens. Anyway, have a good evening. Take care, and we'll see you maybe this weekend, and I will live stream from the field if I have a connection, so I'll be doing that. Okay. Have a good evening.